Today we will see another programming problem which is asked commonly in Google, Amazon and Microsoft interviews. And this problem is to find the second largest node in a binary search tree. So first let's see what is a binary search tree. So it's a binary tree as the name says. And here there is a property that every node in the left subtree of any node is smaller than that node. For example, if we see 50, then it will have two subtrees because it's a binary tree, and all the nodes in this part will have value less than 50. Similarly, if we see 30, we see that the left subtree has just one element, 20, so it's less than 30, and on the right subtree it's 40, which is more than 40. Similarly, in the right subtree of 50, we will see that 70, 75, 80, 90 all are bigger than 50. So this is binary search tree. Now we have to find the second largest element. So here we see that 90 is the largest and this 80 is the second largest. So we know that if we do in order traversal of a binary search tree, then the elements are printed in the sorted order. So if we do in order, then in order means first print all the elements of left subtree, then print the current element, and then print all the elements of right subtree. So if we call this function on root, it will call recursively on this left subtree, and this 30 will in turn call for 20. So 20 will have no left or right subtree, so it will then print the current value, that is 20, and it will return back to calling function 30. So it will then print 30 and then print the right subtree, and then this will return to 50 and it will print 50, and then similarly it will do for the right subtree and it will print 70, 75, 80 and 90. So this is the in order traversal. So we see that all the elements are in the sorted order. So from the in order traversal, you see that one obvious solution would be coming to your mind is that we want the second largest element. So the largest would be in the end because it's sorted. So the second largest would be second last element. So for this, we will need to complete the traversal because we want second last element. So another way is that we can reverse the in order. So traverse the tree in reverse in order way. So here first traverse all the elements of right subtree, then the current node, and then all the elements of left subtree. So in that case it will print 90, 80, 75, 70, 50, 40, 30 and 20. So in reverse in order, it will be at the second position. So we can stop here only. So we will not need to traverse the entire tree. So let's first see what's the algorithm for in order. So in order is that we provide the root node. So we do in order of roots left, then print root, and then do in order of root right. So on the same lines, we can write reverse in order algorithm, and here again we provide the root node. So what we will do, we will change the order. First we will traverse right subtree, then the current node, and then the left subtree. So reverse in order, root right, then print roots data or root node data, and then reverse in order root left. So this will print traverse all the elements in descending order of their value. But we will not do this entire traversal to find the second largest element. So for that, we can keep a counter. So we can modify this algorithm and we will stop when we just print two elements. So we will keep a counter. We can initialize it to 0. And whenever we print any node, we increment the counter. And when count becomes 2, we will print that element and we will not print otherwise. So let's see it in the running code how we can change the reverse in order traversal and find the second element of the binary search tree. So first let's define the structure of tree node. So here we will have two child nodes, left node and right node. And one we will have data, which will contain the data in that node. For now, let's consider it to be int. And then define one constructor for that. So this is the constructor for that node. Now let's write a function to insert elements to a tree. So insert node, it will need the pointer to the root node and the value that we want to insert. So the base case would be that this root node is empty. So if we have root node is null, then we need to create a new node. So we will return a new node and insert that value into it. So it will return just a tree with one node. Otherwise, if it's not null, then that means the tree was already there. So we need to put this value at appropriate position in the tree. So there are two cases. If this value is less than roots data, then we insert in the left subtree. So else, if the value is more than roots data, then we insert in the right subtree. And the third case is that this value is exactly equal to roots data. In that case, we will not insert it because we just keep track of unique values in the tree and we don't want any duplicate values. And finally, we return the updated root. Now let's insert some nodes in the tree. So let's create a root and it's 30. Then let's insert a few values to it. Let's say 20. And we need to put address here because it's node star, node pointer. And then insert a few more values. 40, 50, 10, 25. So this tree will have 5 plus 1, 6 elements, 6 nodes. Now let's start stepwise. So we saw that we will modify this reverse in order and keep track of count. So first task is to just implement the reverse in order. Then we will start modifying it to get our result. So first let's write the reverse in order. And it will take a pointer to the root node. So there may be possibility that the tree is empty, that is root node is null. Then we don't have anything to print, so we will return. Otherwise we will do reverse in order of right subtree, and then we will print the current node's value. And then finally do the reverse in order of left subtree. Now let's call it on the current root. And let's see if it prints correctly or not. So let's put a new line character here. So it correctly prints 50, 40, 30, 25, 20 and 10. That is in descending order of their value. So first task is done. We have implemented the reverse in order. Now we just need the second largest. So let's keep track of a count here. So let's create a new function and we will modify it. Second largest. So currently it's same as reverse in order. Now we will add something. So we will add a counter. So initially it's 0, and whenever we are about to print any value, we will increment count. And now let's print the count also. And let's delete it. And now let's call our this function and let's run it. So now we see that when 50 is printed, count is 1. When 40 is printed, count is 2. So now we have reverse in order as well as their position index. So 50 is first, 1 means largest, 2 means second largest. So now we can use this count. So we can have a check that if count is equal to 2, then print this value, and once we have printed the second largest, we are done. We don't need to traverse further. So we will simply return. Now let's print it. So it prints 42 and nothing else. So 40 is in fact our desired answers because 40 is the second largest. So now let's get rid of this count also. And now let's print it. So it just prints 40. So this way we have implemented our solution. So this is the complete solution, and you see that this can be modified. If we want third largest, we can put here 3. So you see how we can start to approach the problem and then build on top of it. So let's summarize that we were asked to find the second largest element of a binary search tree. So then we saw that in order traversal of tree sorts the elements, prints the elements in sorted order. So we thought that we need second largest, so that is almost, it's near the end, so it's better to do reverse in order. Then we did reverse in order. Then we improved our solution that we don't need to traverse further once we have traversed two elements. And then we added those checks here, like when count is 2, then we are about to print we are traversing the second largest element. So we will print that data and then return. So I hope you understood this problem completely and try to develop this algorithmic thinking and try to build the problem bottom up. So first try to arrive at simple solution, then try to improve it gradually. And this will be very helpful in the interviews at the top firms like Google, Microsoft, Amazon, or Adobe. So all the best and thanks for watching.